Assalamu alaikum. Now we are going to study change of state. This means changing solid state to liquid state and then into gaseous state and vice versa. The equation given over here is that is solid changes to liquid, this is called melting. Liquid changes to gas, this is called evaporation, but at very high temperature it changes into boiling. You have to apply heat over there so that we can change the state. Then vice versa, that is, you have to cool down the gas, it changes into liquid. This process is called condensation. Liquid further cools down to solid, this is called freezing. Now, how we define melting point? The constant temperature at which a pure solid melts is its melting point. Now, over here we have to consider that I am saying that pure solid. Pure solid means that there is no impurity in it. Boiling point, the constant temperature at which the pure liquid boils is its boiling point. Again over here it's pure liquid. Then there is another process which is called sublimation. Some substances can change from solid to gas without changing into liquid. This process is called sublimation. Now again I have written the equation that is solid, when it is heated it directly changes to gas, sublimation, and when the gas is cooled down it changes into solid, that is solidification. Now I have mentioned earlier that is when liquid changes to gas it is two processes, evaporation and boiling. Now evaporation is escape of particles from the surface and can happen at any temperature. Particles having kinetic energy greater than average kinetic energy of the liquid particles tend to come to surface and thus escape into atmosphere. This happens below boiling temperature. Boiling, it occurs when liquid gains energy and its internal vapor pressure becomes equal to the external vapor pressure. The liquid shows vigorous bubbling and gives lots of steam. The temperature shows constant reading. This is the boiling point. Now it is specific for the pure liquid and can be used to identify the liquid. For example, pure water, it boils at 100 degrees centigrade. Ethanol, it boils at 78 degrees centigrade. Now, in this equation, under ethanol, I have written on the left side L, which means liquid. On the right side, under ethanol, I have written G, which means gaseous states. Now, we can show these processes in a given flow chart. Energy changes during, now we study another topic, that is energy changes during change of state. We are talking about the change of states. So, and we are also talking about heating and we are also talking about cooling. So this means that when we apply heat to any substance which is in a solid state, its particles gain kinetic energy. At specific temperatures, particles have different kinetic energies. As we raise the temperature, kinetic energy also increases. And we know that kinetic energy is due to the motion. Now, particles in solid state have least kinetic energy and stay and vibrate at their place and experience high attractive forces among the particles. Liquid particles have more energy and can slide over each other, have less attractive forces, whereas gas particles have highest kinetic energy and can break away the attractive forces and have distances 300 times more than their diameter between each other. Now in this equation I have written about the attractive forces and kinetic energy. Solid has the least, then liquid, and then gas. I hope you have understood this process and how energy change of state takes place. It all depends upon the temperatures and their energies. So vice versa, when you cool down, the temperatures become less, kinetic energies become less, so particles tend to move closer to each other. They will, when they come closer to each other, they will gain attractive forces among each other. So from gases it changes to liquid, and then from liquid it changes into the solid. Remember one thing, that in solid the particles, they do have little bit of kinetic energy. They vibrate at their place and they do not leave their place. That's why Solids, they have specific shape. And in liquids, as the particles they slide over each other, you can pour liquid from one container to another container, and it can also gain the shape of any container. Thank you.